Welcome, plant operators and engineers, to this explainer. I'm really excited you're tuning in today because, well, we're gonna completely master the life cycle of your LG Water Solutions RO membranes. These are seriously advanced pieces of engineering, and treating them right, that's what ensures peak performance, maximizes your plant's uptime, and absolutely crucially protects your warranty. So let's get right into it. Here's our roadmap for today. We'll briefly meet your NanoH2O membrane, walk through proper loading and startup, cover those crucial operating limits, dive into data logging, and wrap up with cleaning and maintenance protocols. Think of your system like a high-performance sports car. It needs the exact right warm-up, a strict respect for the red line, and precise maintenance to keep it running at its absolute best. Okay, let's dive into this. Section 1. Getting to know the actual cutting-edge technology sitting inside your pressure vessels right now. Let's talk about the LG Water Solutions Seawater RO element. Now, what makes this specific element so special is its thin film nanocomposite, or TFN technology. But actually embedding benign nanomaterials directly onto the membrane surface, LG Chem has achieved something pretty amazing. They've boosted the flux by up to 20%. And the absolute best part? It does this without sacrificing a single drop of its salt rejection power. It's a total win-win. Consider the factory performance specs for the LG BW4040R. We're talking about a stabilized salt rejection of 99.6% and a permeate flow rate of 2,500 gallons per day, all while handling maximum applied pressures up to 600 psi. I mean, those are incredibly impressive numbers. But, and this is a massive but here, to maintain that level of factory performance out in the real world, you've got to treat the equipment exactly as the technical manual dictates. Which brings us right to Section 2, proper loading and startup. This is that critical first phase where a lot of costly and, frankly, warranty-voiding mistakes can easily happen before you've even produced a single drop of clean water. I want to speak directly to the operators right now about shimming. Because pressure vessels can vary slightly depending on the manufacturer, you'll often find a bit of slack in the element stack. You absolutely must remove this slack. You do this by seating your elements tight against the reject side end plate and then installing PVC shims over the feed side adapter until it fits perfectly snug. Why is this so vital? Well, if you leave excess slack, the hydraulic forces during startup and shutdown will cause the interconnectors between the elements to literally decouple, and that completely destroys your performance. Next up is purging air. Listen, if you take away only one thing from this startup section, let it be this warning. You must completely purge entrained air from the system with a low-pressure flush. We're talking between 1 and 1.4 bars before you start ramping up the pressure. Failing to do this results in a wildly violent phenomenon known as water hammer. Basically, high-pressure water slams into pockets of trapped air, creating these massive hydraulic shock waves that will physically crack the fiberglass shells and telescope the elements. It instantly destroys your membrane. There's no going back from that. Now for the golden rules of safe startup. First, your concentrate control valve absolutely must be fully open. If you fire up the train with this valve closed, you're going to rapidly overpressurize the system. And that won't just ruin the membrane, it can actually burst your piping and create a massive, very real safety hazard for anyone standing on the plant floor. Also, make sure your permeate valves are open to drain, and never ever pressurize the system faster than 0.7 bars. That's about 10 psi per second. Smooth and steady is the only way to win the race here. Moving right along to Section 3, crucial operating limits. Think of these as your operational red lines. If you want to keep your membrane alive and your warranty valid, you absolutely cannot cross these lines. First red line to watch, free chlorine. Your feed water must contain less than 0.1 parts per million of free chlorine. Now sure, the LG NanoH2O membrane does have a tiny bit of resistance to very short-term exposure, but continuous exposure to chlorine literally oxidizes the membrane surface. It's essentially a chemical burn. It permanently ruins the rejection capabilities of the element. And because it's completely avoidable, oxidation damage will instantly void your LG Chem warranty. It's just not worth the risk. Second red line is temperature. The absolute maximum operating temperature here is 45 degrees Celsius or 113 degrees Fahrenheit. If you start pushing water hotter than this through the system under high pressure, the porous polysulfone support layer right beneath the thin film membrane will weaken and compress. This compaction permanently cripples your permeate flow, and just like the chlorine damage, it is 100% irreversible. And this brilliantly illustrates why truly understanding the physics of your system is so important for troubleshooting. If you see a problem, you immediately need to know, am I losing flow or am I gaining salt? Reduced permeate flow is usually caused by lower feed water temperatures, a drop in feed pressure, or just general fouling on the membrane surface. On the flip side, increased salinity in your permeate usually points to mechanical issues, things like O-ring leaks, that dreaded chlorine oxidation we just covered, or simply pushing your recovery rates way too high. Here is another absolute hard and fast rule. Never, ever expose your RO elements to permeate back pressure that exceeds the feed pressure. This usually sneaks up on you during a shutdown if the permeate valves get closed too early. Closing that valve creates a pressure differential that actually flows backwards, rupturing the glue lines inside the element. Let me be perfectly clear here. A ruptured glue line is an instant, irreversible death sentence for that membrane. You always want to keep those permeate valves open during operation, flushing, and cleaning. Let's pivot to Section 4, Data Logging for Success. This section is really all about those daily habits required to keep the plant running smoothly. Think of data logging as your early warning radar system. To actually make sense of your data, you have to understand normalization. Now, I know it sounds like heavy math, but conceptually, it's really simple. Because a drop in temperature naturally lowers permeate flow, you might walk in on a cold Tuesday and mistakenly think your membrane is failing. Normalization just uses a standard formula to strip away those environmental changes. It allows you to compare today's performance directly to the baseline performance you had on day one. It's basically a way to compare apples to apples, so you aren't being tricked by a hot or cold weather day. Listen, there are absolute minimum logging requirements you have to meet. You need to be checking your silt density index, your temperature, and your conductivity at least once a day. Turbidity, flow, and pressure, those need to be logged once every 8-hour shift. If you aren't diligently logging this baseline data, you are flying completely blind. Without it, you can't normalize your performance. You won't actually know when to clean, and crucially, LG Chem can void your warranty if you can't provide these exact logs when you try to make a claim. Finally, we arrive at Section 5, Cleaning and Maintenance Protocols. Look, no matter how perfect your pretreatment is, you are inevitably going to deal with a buildup of foulants. That's just the reality of reverse osmosis. So the crucial point is knowing exactly when it's time to clean. For that, we use the 10-10-15 rule. Do not wait for total system failure. You want to clean when your normalized permeate flow drops by 10%, or when your normalized salt passage increases by 10%, or when your pressure differential from feed to concentrate goes up by 15%. If you procrastinate and wait until these numbers hit 20 or 30%, those foulants might be so baked in that no amount of chemical cleaning will save the membrane. When it finally is time to clean, here is your standard protocol. First off, always flush the vessels with RO permeate to push out the process water. Then, you generally want to attack biological and organic foulants first by recirculating a high pH sodium hydroxide solution. After flushing that all out, you follow up with a low pH citric acid solution to dissolve the mineral scale. Oh, and to the technicians actually doing this, make absolutely sure your cleaning flow travels in the exact same direction as your normal feed flow. You never want to clean in reverse. Now, if you are taking the system offline for a while, you've got to prevent biological growth. The manual approves a few generic biocides for this exact purpose, including glutaraldehyde, isoxazoline, which you might know as Cathon, and sodium bisulfite. Using these at the correct manual-specified concentrations is going to stop algae and mold dead in its tracks during storage, all without degrading your membrane materials. But you must be incredibly careful if you use hydrogen peroxide. Yes, a very weak solution can technically be used for disinfection under strict conditions, but there is a massive hidden danger here. If there are any transition metals in your feed water, things like iron or manganese, and you introduce hydrogen peroxide, you're going to trigger a severe catalytic reaction. This will instantly and irreversibly oxidize and destroy the elements. Bottom line, if you have iron anywhere in your water, keep hydrogen peroxide far, far away from your system. Which brings us right to the end of our life cycle journey today. Let me ask you, are your daily logs telling you the true story of your plant? I want to challenge every operator watching this explainer to go look at your clipboard today. Are you just writing down raw numbers to fill a box, or are you actively calculating your normalized data? Because the true health of your LG NanoH2O membranes, and really the success of your entire plant, lives inside those normalized trends. Go find out what story your data is telling you today. Thanks so much for joining me on this explainer, and keep that water flowing clean.